Hello friends, welcome to Notebook. In your previous curriculum of Class 9, you have read about the basic meaning and concepts of probability. In the current curriculum, we will continue with our studies on the topic in further detail. In fact, all the different kinds of problems that we have discussed, we will discuss them again. Just that they'll be a little more complicated. For example, in place of one coin, we will now see problems on flipping of 2 coins and 2 dice instead of 1 and so on. Before we discuss trickier problems, let us see the definitions and terms on probability. There are 3 main ways by which we can define probability: empirical, theoretical, and geometrical. Empirical probability of an event is given by PE is equal to number of trials in which E has happened divided by total number of trials. Theoretical probability is also popularly known as the classical probability. A sample space has n numbered outcomes. Each of these outcomes is equally likely to happen. An event A occurs in m number of outcomes, where m is less than n. Then, the theoretical or classical probability would be PA is equal to number of favorable outcomes divided by number of possible outcomes, which is equal to m by n. These 2 theories and formulas we have more or less covered in our previous class. There is yet another approach to probability called geometric probability. When we find the probability of occurrence of any event, then normally the event is a discrete one. That is, the value or the numbers attached to it is a unique number, and we find the probability by dividing the number of outcomes favorable to our required event with the total number of outcomes that can possibly occur other than the required event. Whereas when we are finding a geometric probability, the first difference from normal probability is that here the event is not a discrete or a unique one, but a continuous event. In case of geometric probability, we are mostly concerned with the area, length, breadth, or volume. That is, here we mostly find the probability of occurrence of an event around an area by dividing the required area by the total area concerned. In geometric probability, the formula for finding the probability is given as P is equal to measure of specified part of the region divided by measure of the whole region. Here, quote-unquote measure is the length, area or volume of the region or space. In order to be able to solve problems based on these 3 formulas, let us revise the terms and concepts in the study of probability that you have learned in your previous class. Experiment. Any process which yields well-defined outcomes is called an experiment. Random experiment. An experiment which, when repeated under identical condition, does not yield same result every time is called a random experiment. Trial. Each possible outcome is called a trial. Outcome. A particular result of a random experiment is an outcome. Sample space. A set of all the possible outcomes is called a sample space. Event. Any outcome from the sample space is called the event. If PE is equal to 0, then the event is called an impossible event, where E is any event. Example, we know that a single die has 6 faces and the outcomes on rolling a single die varies between 1 to 6. Thus, the probability of getting any value less than 0 on rolling a dice is 0. Hence, it is an impossible event. If PE is equal to 1, then the event is called a sure event, where E is any event. Example, we know that when a single coin is tossed, the total number of outcomes is 2, that are a head and a tail. Since there is only one head and only one tail, then the probability of getting a head or tail on tossing a coin is 1. Hence, it is a sure event. Equally likely outcome. In some random experiment cases, it is assumed or estimated that the occurrence of any outcome from the sample space has equal probability to another outcome from the same sample space. Example, when we toss a coin, the probability of getting a head or tail is equal to 1 by 2. Since there are only 2 possible outcomes, that is, a head and a tail. If A implies B, the PA is less than equal to PB, sum of all probabilities. If there exists 3 events, E1, E2, E3, and the probability of the occurrence of these events are PE1, PE2, PE3, then the sum of these probabilities would be PE1 plus PE2 plus PE3 is equal to 1. Similarly, if there exists n number of events, E1, E2 up till En, and the probability of occurrence of these events are PE1, PE2 up till PEN, then the sum of the probabilities would be PE1 plus PE2 plus up till PEN is equal to 1. Did you notice that while defining probability in 3 different approaches, we consider the random variable as discrete in case of empirical and theoretical theories, while for geometric probability, the random variable is continuous. Do you know what a random variable is? A random variable is a variable taking on numerical values determined by the outcome of a random phenomenon. A discrete random variable has a countable number of possible values. A continuous random variable is a random variable where the data can take infinitely many values. Also, the difference between an empirical definition and a theoretical definition is that empirical definition is found by repeating an experiment and observing the outcomes. It is experimental probability. Theoretical probability, on the other hand, is what is expected to happen based on mathematics. Now that we have seen the main topics to remember when obtaining probability of any event, usual problems that you face in your exams will be easier to solve. As usual, we will deal with problems on dice, coin, cards, and objects in a box or bag. Catch us in our subsequent videos as we will tackle each type one at a time. See you soon. Goodbye.